this lecture, I'm going to review how to name acids. And I'm using a worksheet that I got from a colleague of mine many years ago who has long since retired and enjoying his time off from teaching, Charlie Buckle. Thank you very much. A nice worksheet that didn't have to recreate the wheel when he gave this to me years ago, so I'm using it still. Thank you very much. But here are the rules to name your acids. And as we have here, we have our binary acids and our ternary acids. Binary, just like our salts, are two different elements like HCl, HBr, HI, and so forth. And when you have a binary acid, when you just have two different elements, of course you see the H in front denoting that it likes to donate an H like a Bronston-Lowry acid. Okay, we put the word hydro in front and we add the ic. So HCl becomes hydro. Now we have to put chlor ic acid. So you can see that the hydro and the ic, are surrounding the chlor. This is hydrobromic acid, hydroiodic acid, yes. Okay, then we can have something like H2S, hydrosulfur, hydrosulfuric. So anytime you got a binary acid, the hydro goes in front and we add the ic. All right, so hydrosulfuric acid. All right, pretty simple. And let's go through ternary acids. Now, ternary acids, like ternary salts, we have the table E type of polyatomic ions involved. For instance, if I've got NO3 minus 1, and of course if I've got an H in front, that means H is a plus, it's a proton. So how do I name these? Well, these are a little more complicated, but we take the name of the polyatomic ion, that grouping of nonmetals that are sharing electrons but needing to gain electron to make it stable, and we look at its name. Now this is a nitrate ion. So we look at the name, and since it ends in ate, ates become ic. So this does not become hydroic because it's not what? It's not binary. There's more than two. So we just take the nitrate ion and we take away the ate off and we add ic. So nitric or nitric acid. Right? Nitrate became nitric. Okay? If I have H2SO4, also ternary, there's more than two here. So this has the what? This has the sulfate ion in it. If you need to go to table E to see that, sulfate. So this becomes sulfuric. Sulfic. You may say, well, what about sulfic? Well, the furic is just to make it sound nice, I guess, phonetically. Sulfic, I get it, but sulfuric is what we use for that, and that's a strong acid. So if it's an 8, it becomes an ic from the name of the polyatomic ion. So the name of the acid is from the polyatomic ion. Whereas the binary, the name of the acid, is jumped around the element involved. Since it's binary, the hydro and the ic wrap around the element. Whereas the ternary acid, which has a polyatomic ion, that's the name of the acid. Ic if it's 8, and if it's an ite, it becomes OUS. For instance, H2SO3. This is the sulfite ion. As you'll learn, ites have less than 8s. 8 has more what? Oxygens. SO4 is the sulfate ion. SO3 is the sulfite ion. Ite is less. But in any case, if you've got an ite, and you can identify that from a table, you know that if there's H's in front, in this case H2SO3, you need two of them because one sulfite ion is -2, so you need two +2s to make it neutral. The name of this is you take the name of the polyatomic ion, in this case sulfite becomes sulfurous, OUS. Now again, the sulfur there kind of makes it phonetically sound better, but you add, for the ite, you add OUS. So sulfurous acid, We have sulfuric. This is sulfuric. Sulfurous. Then we have hydrogen sulfuric acid. You can see the differences there. There's the binary hydrosulfuric. This is the 8, so it becomes ic, so it becomes sulfuric. This is the ite polyatomic ion, so it's sulfurous acid. And that's it. So let's go look at some examples. So HNO3, as we've done before. Now this International Units Conference, sometimes called, most of the time I should say, is called IUPAC. Okay, I guess I put two I's there. So IUPAC is the name of the conference that we got together to name elements. Okay, so there's some standardization in the naming. So HNO3, well, if you use the standard IUPAC name for this chemical, we would use hydrogen because it's in front, right? Nitrate. It's how you would name any salt or any compound, positive part in front. So we can actually name this acid as it was if it was a salt. Now, of course, it's not a salt, but it does follow the same idea because the H is positive and the rest of the conjugate base is negative. Acid name, well, because it is a polyatomic ion, NO3, that's the nitrate, 8 becomes ic. This is nitric acid. Now, the name and formula of the salt of this acid depends on the base. Let's all pretend that the base being added to this, let's say acid-base reaction, is NaOH. So the salt could be sodium nitrate. And I'm not going to write the name. Sodium nitrate. So if you added a base to the acid, as we've learned, an acid plus base makes salt and water. This is the salt you'd make. Okay, H3PO4. Oh, wait a minute. This is polyatomic ion. This is the phosphate. The name of this would be hydrogen phosphate. And the acid name is, well, phosphate becomes ic. This becomes phosphoric acid. Let me just make this because phosphoric acid. It's a weak acid. It's a polyprotic acid. And so hydrogen phosphate. It's the phosphate. 8 becomes X. Phosphoric acid. Name of the salt will be sodium. You need 3 of them because the phosphate ion is -3. Sodium phosphate. Okay. This right here seems like, what the heck is that? Well, this is an acetate ion. Acetate. Okay, so we have hydrogen acetate, which is vinegar. If you're from West Hampton, it's vinegar. Okay, so acetate ion. Okay, wait a minute, the acetate, 8 becomes ic, this becomes acetic, or we say acetic acid. And salt could be, well, I know the acetate ion is -1. I know that because of 1H, or I can look it up. And vinegar, we can write it this way. The salt of this acid should be sodium acetate. And I can write it a couple different ways. C2H3O2, or I can write it just an Na in front. This is the molecular formula. This is the structural formula of acetate, as we'll see in organic chemistry. All right, next one is the sulfate ion. It's a ternary compound, so it's hydrogen sulfate for the IUPAC name. And this would be, of course, sulfate becomes ic, so this is sulfuric acid. And the salt would be Na2SO4. Why is that? because each sulfate is -2. And I know that because I can look it up, or there's 2 H's per one of those sulfates. H2SO3, this is the sulfite ion. So again, IUPAC name, easy. name it as you would name a regular salt, hydrogen sulfite, but because of the ITE, it becomes OUS, so sulfurous acid. Salt name, well, the sulfite's -2, so you need Na2SO3, that's sodium sulfite. All right, let's go down to these guys. ClO, well, that is the hypochlorite ion. So this is the hypochlorite ion. All right, again, it's something you either know or you can go to your table. So this would be hydrogen, not enough space for this, hypochlorite. Now, hypo means what? Less. And the reason why there is because there's 4 of these. Interesting enough. These 2 will be 8s. These 2 are ites because they have less. And the one that has the least amount of O's would be the hypo, less of the ites. Okay? So in any case, that's a lot of fun you could not use sometime in your other parts of your life, but hypochlorite. So the name of this is, well, hypochlorite. Ite becomes OUS. So this becomes hypochlorous acid. And this is what you'd have if you dumped Clorox into your pool. And Clorox is bleach, so bleach in water makes hypochlorous acid. That's actually the disinfectant that kills the bacteria. And that, of course, would be a -1 because there's 1 hypochlorite ion per H, so it's sodium hypochlorite. And that's how it comes in the bottle. All right, well, this is also an ite, so this is chlorite. Now, why is it chlorite, not hypo? Well, hypo is the least of the chlorite. These are the ites, and these are the 8s. 8s mean more. So this is chlorite. So this is hydrogen chlorite. And of course, ites become OUS, so this becomes chlorous acid. By the way, these 2 are weak acids. Okay, and of course this would be sodium chlorous, chlorite acid. Sodium hypochlorite. This is sodium chlorite. I can do this. Sodium hypochlorite, sodium chlorite. Okay. And HCl3, well, these have more O's than these guys, ClO3. So these are the 8s. Now, this one is a chlorate. So a chlorate, Cl, I can do this, chlorate. So this is hydrogen chlorate. And H's become ick, so this becomes chloric acid. And this is a strong acid, believe it or not. We have a top 5 acid in our table L. We would include both of these. As we add more O's, this electronegative O's, the 3 of them, pull the H, or the electrons in the H, away from the Cl and make the H come off and have very, very high Ka. So this is sodium chlorate. I'm sorry, chlorate. I can just confusing myself here. ClO3. So sodium chlorate. All right, now this one, because it has more 8s or more O's than the other 8, we call this perchichloric, or perchichlorate, I should say. Perchichlorate. All right, and probably didn't spell that right. There's no A in between. Perchichlorate. Perchichlorate, ATE. So this is hydrogen perchlorate is the IUPAC name. And then, of course, this would be now, 8 becomes hypochlorous acid. Also a strong acid. All right, let's make that a little nicer. Getting excited as I write these. So perchloric acid. Of course, that'd be Na, ClO4. These, of course, are strong acids. We would include those with our top 5. Okay, HNO3. I think we had that one already. So let's make that HNO2. That's a what? That's a nitrite ion. So this would be hydrogen nitrite. And this would be, whoa, IT, this would be nitrous acid. Yeah. This would be Na, NO2. Yeah, so that should be a 2 there. HF, that's binary. Still, the IUPAC name is hydrogen fluoride. All right, fluoride. Spelling leaves me. And then, of course, we have the name, because binary, it's hydrofluoric acid. And that is sodium fluoride, and that's, of course, the active ingredient in your toothpaste, salt. So we have hydrogen carbonate, right? Carbonate becomes the ick. So this is hydrogen carbonate, and this is carbonic acid. And the salt would be Na2CO3 because each carbonate's -2. And this would be hydrogen carbonate. Pretty easy stuff. And this is oxalate. Again, a polyatomic ion you can look up. So this is hydrogen oxalate. I'm done with that color. And this is, of course, 8 becomes ick, so this is oxalic acid. And the salt, because the oxalate guy is -2, is Na2C2O4. And last one, HBr, a binary. So this is hydrogen bromide. And this is what? Hydro, because it's what? Binary, hydro, bromic, ick and hydro surround the bromide acid. Just like we had what? The binary HF. Okay, they're the same thing. Hydrofluoric acid, hydrobromic acid. The hydro and the ick surround the element. And the salt of that would be sodium bromide. Okay, any case, pretty easy to name them. Just think of your rules. Binary, you have 2 different elements. You put hydro in front and an ick. If it's a ternary element more than 2, the name of the polyatomic ion drives the name. If it's an 8, it becomes an ick. And if it's ite, it becomes an OUS. Okay, there it goes.